Good afternoon. I'm sorry that I can't be here with you today. I am not feeling well, but we are going to talk about 5.4, just to find and verify inverse functions. So in math, functions that undo each other are called inverse functions. The graph of an inverse function is always reflected over the line y equals x. So we can see that here. That here we have the line y equals x, and these two functions are reflecting over that line, and they are inverse functions. So when you look at the table here for the blue one, we see that we have -2, -1, 0, 1, 2 goes with these output values. -1, 1, 3, 5, 7. The inverse function, which we see right below it, has just switched the x and y. So here we can see that x and y switched from what we see in the blue one. So this is what it looks like in a table form. And then on the right is what we see in a graphing form. Also, you should notice, so for the blue one, we have 2x plus 3, and so we're taking x, we're multiplying it by 2, we're adding 3, and the inverse of this is taking x, instead of adding 3, subtracting 3, instead of multiplying by 2, dividing by 2. Okay, so this is the first inverse function that we have. If you want to think about graphically, so we're going to be looking at the blue function. If the graph passes the vertical line test, the graph itself is a function. So remember, our vertical line test tells us, okay, can we draw a vertical line and make the graph touch itself? We cannot, so this would be a function. So yes, this is true. The blue one is a function. The next one is the horizontal line test, which we haven't talked about, but same concept, except going horizontal. So if you cannot draw a horizontal line to make the graph touch itself, then it would pass the horizontal line test, making its inverse a function. So this works. Its inverse is a function. If both of them are true, where it passes the vertical line test and the horizontal line test, then that is a one-to-one function, which in this case, it is. So those are a couple of things about how we look at inverse functions. Now we're going to talk about actually solving. So, as long as I can move this down. Uh-oh. I'm playing with technology. All right. Okay, so for our inverse functions, I had written it here, but it's gone. It's okay. For our inverse functions, there's there's two steps. One, because they're inverses, we're going to switch x and y. And two, the way that we always have our functions is we have them solved for y in terms of x. So let's do an example. It says to find the inverse of f of x equals 3x minus 1. So really that's y equals 3x minus 1. So our first step is going to be to switch x and y. So I'm just going to do a different color. So we're going to switch x and y. So that means we're going to have x equals 3y minus 1. And then we just have to solve that equation for y. So first we would subtract 1. So we would have x minus 1 equals 3y. And then to get y all alone, we need to divide by 3. So we divide each side by 3, and we get y equals x minus 1 divided by 3. And then that's it. So a linear function, its inverse is going to be another linear function. If we're talking about quadratics, like we are in the next one, we have y equals x squared. And you should be able to recognize in your head that the inverse of a square is a square root. But so we have y equals x squared, and now we switch x and y. So x equals y squared. And then the second step is just to solve for y. So I need to get y alone, so I take the square root of both sides. And we would put a plus or minus here. So y equals plus or minus the square root of x. But we do have to be careful because it is telling us here that we are just looking for values where x is greater than or equal to 0. So that is just going to be positive x squared. So our answer here for this inverse, we're not going to have that minus sign, but you should recognize that it was an option. And if we didn't have it saying that it's x is greater than or equal to 0, we'd need both parts. So the inverse of this square is the square root. A cubic, you should recognize that the inverse is going to be a cube root function. But so we have y equals 2x to the third plus 1. We're going to switch x and y and then solve for y. So here I have done x equals 2y to the third plus 1, subtracted 1, and divided by 3. Or divided by 2. So now to get the cube root alone, I can either do like the cubic thing where I actually write it out, or you could also write to the 1/3 power. So that would be the same thing. We don't ever put a plus or minus when we are finding an odd root of something. So you could write it as the cube root of x minus 1 over 2, or x minus 1 over 2 to the 1/3 power. Okay? And then lastly, if we have a radical. So we're going to switch x and y right away, cutting out that intermediate step. So x equals 2 times the square root of y minus 3. So now we're going to solve for y. So first we're going to divide by 2. So x divided by 2 equals the square root of y minus 3. And it is important that we divide by 2 first. We are not going to do anything about the square root until we have it all by itself. And now to get rid of a square root, we're going to square both sides. We are going to square both sides and then add 3. And we get our answer. Y equals x over 2 squared plus 3. You don't need to turn this into x squared over 4, but you should recognize that it would be equivalent to x squared over 4 plus 3. Okay, the last part is verifying when functions are inverses. So when functions are inverses, it means that they undo each other. And this means that if f of g of x equals x, they would completely undo each other because they're reflecting over the line y equals x. It also has to be true then that g of f of x must be x. If these things are true, then you have an inverse function. I guess I shouldn't say you have, but they are inverses. So what I can do is plug one function into the other one and make sure that I get x. So we will do an example. Okay. So verify that f of x equals 3x minus 1 and g of x equals x plus 1 over 3 are inverse functions. And to do that, I'm going to find either f of g of x or g of f of x. So f of g of x means I'm taking g and plugging it into f. So 3x minus 1, but now I'm going to take g. I'm going to plug it into f. So 3 times x plus 1 over 3 minus 1. So I make sure that this is going to work. So this 3 and this 3, they will cancel each other out, and we have x plus 1 minus 1, so we get x. So f of g of x equals x. F of g of x equals x. So the first one in this example is good. So now we need to do the same for the second one. So now we're going to do g of f of x. I'm taking f, and now I'm going to take f, and I'm going to put it in here for g. So we're going to have, instead of x plus 1, we're going to have 3x minus 1 plus 1, right? You see this plus 1, and then divide that by 3. So we look at the top, we have 3x minus 1 plus 1. The 1's cancel each other out, and then we're left with 3x over 3. 3x over 3 does equal x. So we see that g of f of x equals x. That's true. So the reason it needs to equal x is because these lines reflect over the line y equals x. So here's the y equals x. So this is what we're doing for inverse functions. And there's a Kahoot for you to practice this with. Please make sure you use your name. I will see you next week.